focus on homogeneous reaction. So for now, we will focus on heterogeneous catalytic reaction. Okay. All right, so for the course learning outcome in this topic, by end of this topic, you should be able to explain the steps in catalytic reactions, write the mechanism and chemical kinetics. And then you should be able to describe the rate limiting step, and finally able to describe Lamuir-Hisherwood kinetic mechanism. So before you're able to describe the rate limiting and Lamuir-Hisherwood kinetic step, you should know what is the steps involved in the catalytic reaction, write the mechanism and chemical kinetics. So actually this is the most important part. So bila you dah you know how to write the mechanism and chemical kinetic, write the rate law, baru you boleh solvekan the problem regarding the rate limiting step and Lamuir-Hisherwood kinetic mechanism. Okay, so the lecture online for this topic, first we will look at the definition of catalyst, the function of catalyst, steps involved in heterogeneous catalytic reaction, rate limiting steps, temperature dependence of catalytic reaction rates, Lamuir-Hisherwood kinetic, designing catalytic reactors, and finally the activation of catalyst. So if you look at your lesson plan, for this topic is required around 2.5 weeks, but actually apa yang the suitable time to finish the lecture for this topic actually it's required around 3 weeks. Okay, kalau 2.5 weeks tu is still not enough. Okay, macam terkejar-kejar lah. Alright. First, we look at the definition of catalyst. What is the function of catalyst? So previously you have learned about enzyme. So actually the function of enzyme itself similar with the function of catalyst. So the catalyst ni, we use it to accelerate the reaction. So a catalyst is a substance that affects the rate of reaction but emerge from the process unchanged. So actually catalyst not involved in the reaction. The function of catalyst just to accelerate the rate of reaction. Okay. So let's say kalau in terms of number of moles, whatever number of moles in the inlet stream of the reaction, so it will come out as the same amount. So let's say the amount of catalyst that you use is 100 gram. Therefore, after the reaction occur, the amount of catalyst still maintained as 100 gram because catalyst not involved in the reaction. Okay, but how the catalyst take part in the reaction? So actually, if you look at this figure, okay, so if you look at this figure, so the starting material here is the reactant. So this is the reactant. This one also the reactant. This is the reactant. The
Doktor, figure tak nampak.
Ya,
Doktor.
tak nampak?
Doktor, sorry. Macam ni part 2 punya slide.
Part 2? Tak, part 1.
Tak
Saya
yang
rasa slide tak bergerak
Doktor
kot,
share
Doktor.
screen.
Oh, tak bergerak.
Yeah. Tak nampak figure yang Doktor explain.
Yang ni, kalau macam ni nampak tak?
Dia keluar yang Y.
Ha? Oh ya ke? Dia keluar yang ni. Ni nampak tak?
Mass transfer
nampak.
coefficient.
Oh, yang ni nampak. Yang slide yang saya tengah cerita tak nampak?
Ya, tak nampak. Tadi
Oh, kejap saya tukar balik. Stop presenting balik lah kot. Stop. Mana dia stop presenting? Dah kenapa dia lain pula keluarnya? Share balik. Saya tutup part tu. Okay, kita try balik share. Lah. Kenapa tak boleh share? Sudah. Hmm. Share window. Kalau ni nampak? Ni nampak?
Nampak.
Nampak doktor?
Okey, nampak yang catalyst ni?
Ya, catalyst.
Okey, kalau saya ni kan, ni still nampak?
Nampak lagi.
So yang ni yang saya tengah explain.
Oh,
Okay, so kita ni baliklah yang tadi dengar kan. So saya start balik dekat sini lah. Explanation dekat sini lah balik Okay, so pointer option. Alright. Okay, so how the catalyst works in the reaction. So this is the two reactants. So usually when we conduct the reaction, it's involve one reactant, at least one reactant, or two reactants kan. So this is example for two reactants process. Okay, the black and the red one. And then this is the catalyst. So how the catalyst involved in the reaction is the reactants to actually they are absorbed on the active surface of catalyst. So if you look at this figure, so this is how it will absorb on the catalyst. So after the reactants ni absorb on the active side of the catalyst ataupun surface of the catalyst, so it will form an intermediate product. So absorption process ni we can call it as an intermediate product lah. And then the reaction occur to produce the product. So this is the product, and the catalyst leave it as its initial form. Okay, so it will not change in the shape. Okay, the catalyst still maintain, except the effectiveness of the catalyst itself to accelerate the reaction. Then it will reduce lah. So the effectiveness of the catalyst to accelerate the reaction will reduce. But the shape of the catalyst, the properties of catalyst still maintain. Okay, so this is how the catalyst take part in the reaction. So a catalyst usually change a reaction rate by promoting a different molecular path or the mechanism for the reaction. So it means that the path to meaning that how the reaction occur. Okay, so because for the catalytic reaction, it can be occur more than one step of reaction. So the function of catalyst, a part of the function of catalyst to determine the reaction path. Okay, reaction path ni meaning that how to control the activation energy involved in the reaction. So if you look at this figure, so when the reaction involve catalyst, so the red line, when the reaction involve catalyst, therefore the activation energy required for the reaction to occur will reduce compared to without catalyst. Without the reaction, for the reaction without catalyst. So reaction without catalyst, the black line. So the activation energy required for the reaction without catalyst is higher compared to the reaction with a catalyst. So catalysts affect yield and selectivity. So why the catalyst will affect the yield and selectivity? Because of the second function of catalyst tadi, to determine the reaction path. So it will choose which step that will increase the formation of desired product. So that's why it will affect the yield and selectivity. If you remember, you have learned about the selectivity and yield during the reaction engineering 1, especially for parallel reaction and series reaction. So we will focus on the selectivity and the yield of reaction. So if reaction involve more than one steps of reaction, so we need to focus which step is the desired reaction. So the catalyst will determine in which mechanism the reaction will occur to increase the desired reaction. So that's why the catalyst will affect the yield and selectivity. Okay, when the reaction involves catalyst, the change only on the rate of reaction. It does not affect the equilibrium. Okay, because the function is to increase the rate of reaction, so that's why only the rate of reaction will change. Okay, catalysts that speed the reaction are called positive catalysts, while slow the reaction are called inhibitors. So this is how it works. Okay, substances that increase the activity of catalysts are called promoters, and substances that deactivate the catalyst are called catalytic poisons. So this is another additional substance that involved in the reaction, either to increase the activity of catalyst or to deactivate the catalyst. So yang catalytic poisons ni we will learn about it during the catalyst deactivation. Okay, how the how the substance can deactivate the catalyst. So this is again the example of reaction that involve catalyst, gas reaction. So usually heterogeneous reaction for gas reaction will involve catalyst, so solid catalyst. So gases reaction between hydrogen and oxygen are inert at room temperature. They react rapidly when exposed to platinum as catalyst. So gas phase reaction with a solid platinum catalyst. So this is how the reaction occur. This is the activation energy required with the if the reaction involve catalyst. So compared to without catalyst, so this is the activation energy required. So you can see the difference here. Right. So the key aspect of catalyst action taking part in the reaction, it will change itself during the process by interacting with other reactant or product molecule. So how it will interact with the reactant and product? So tadi, as I mentioned in previous slide, the reactant will absorb on the active side of catalyst ataupun on the active side surface of the catalyst, and then the product will form on the active side of the catalyst before it will dissolve from the catalyst. So later we will see step by step on how the reaction on the surface of catalyst occur. Okay, altering the rates of reaction. In most cases, the rates of reactions are increased by the action of catalyst. However, in some situations, the rates of undesired reactions are selectively suppressed. So this is, we also can use a catalyst to reduce the formation of undesired reaction. So returning to its original, so as I mentioned before, the properties will not change, the shape will not change after the reaction. So after reaction cycles, a catalyst with exactly the same nature is reborn. In practice, a catalyst has its lifespan. It deactivates gradually during use. So yang ni is about the effectiveness of the catalyst. So the effectivity of the catalyst will reduce after a few cycles of reaction. Okay, so this is the example of catalyst that used in industry. And the size of shape of catalyst is depends on the process. Okay, either dia dalam bentuk powder, so powder catalyst, still we call it as a solid catalyst. Okay, the shape is sama. Either it is a round, ada juga yang catalyst a film. Kalau you tengok kat sini tubular shape, so based on this table ada yang bentuk spheres. Okay, and then there's a lot of type ataupun shapes of catalyst available in the industry, and how we can arrange the catalyst in the reactor. So if you look at the first example is packed bed catalyst. So remember packed bed reactor. So this is how we arrange the catalyst as a catalyst bed. So just rearrange it as a in the vessel as a bed of catalyst. And one of these catalysts, you can see the it is a either it is non-porous or porous. Usually we will choose porous catalyst because we need to increase the surface of reaction where the reaction can occur. So that's why we choose porous catalyst compared to non-porous catalyst. So porous catalyst, there's a lot of surface active area ataupun active surface of catalyst that available for the reactant to absorb. Okay. Dan ada juga yang bentuk film ataupun catalyst pellet. Okay, what is the definition of catalysis? Catalysis is the change in rate of a chemical reaction due to the participation of an additional substance called a catalyst. So the reaction that involve catalyst, we also can call it as a catalysis reaction. Okay. Also, catalysis is the occurrence, study, and use of catalyst and catalytic process. So usually we just call it as a chemical catalytic reaction. So that's the long name. We also can call it as a catalysis. So catalysis we simplify the name of the reaction. Right. Then we look at the type of catalyst. So type of catalyst, it can be gas, liquid, or solid. But usually we will use liquid phase or solid phase. Okay, kalau untuk gas phase reaction, usually we will use solid catalyst. Okay, kalau liquid catalyst ni, usually for homogeneous reaction, yes, we will use liquid catalyst. And some of the solid catalyst, okay, kalau before the reaction occur, the catalyst is in form of solid, and then this solid catalyst reacted with liquid reactant. And at the same time, the solid catalyst can be dissolved in the liquid phase. So we call it as a homogeneous reaction. So tak semestinya solid catalyst when reacted with liquid, the reaction occur as a heterogeneous. So it can be the reaction can become homogeneous, okay, when the solid catalyst dissolve in the liquid phase. So for certain case, liquid reaction, for example, transesterification of reaction, the reaction that involve alcohol and oleic acid, the catalyst required for the reaction is solid catalyst, solid and AOH. So when the reaction conducted at 70 degrees C, for example, then the solid NaOH will dissolve in the liquid reactants. Therefore, the reaction becomes homogeneous. Okay, but if the reaction with liquid or gas, reaction with liquid or gas, when the reactant is liquid or gas, the catalyst is solid and the phase is maintained. Okay, for example, aluminum or platinum solid catalyst. So the phase of catalyst maintained as a solid during the reaction. So we call it as a heterogeneous reaction because the phase of catalyst still maintained as a solid. Okay, dia tak berubah. Right. Classification is based on the substance from which a catalyst is made. So it can be classified as an inorganic catalyst and organic catalyst. So this is the example of inorganic catalyst. So kalau metals such as aluminum, platinum, palladium, so we call it as an inorganic catalyst. And then organic enzyme is one of example of organic catalyst. So classification based on the ways of catalyst work. So yang saya explain tadi, homogeneous, both catalysts and all reactants or products are in the same phase, gas or liquid. So macam saya cakap tadi, if the catalyst is solid, reactants is liquid, but the solid catalyst can dissolve in the liquid reactant, so it becomes homogeneous. Heterogeneous reaction system involve multi-phase catalyst and reactant. So kalau multi-phase ni, it can be solid liquid gas phase reaction. So we call it as a multi-phase reaction. Or solid liquid, solid gas. So both reaction is heterogeneous and multi-phase reaction. Okay, then classification of catalysts. It also can be classified based on the catalyst action, either acid-base catalyst, enzymatic, photocatalysis, or electrocatalysis. Okay, so this is just for your information. But the most important part, you need to know how to differentiate. Either the reaction is homogeneous or heterogeneous, because this is important when you want to conduct your design project later in part 7 and part 8. So that's why this part is very important. So you need to know how to differentiate either it is homogeneous or heterogeneous. So again, ada yang still confused, especially your senior sekarang ni pun still ada yang confused. Reaction is liquid phase and then the catalyst solid and then dissolve. They still classify it as a heterogeneous. So sepatutnya it can be classified as a homogeneous. Okay. So why we need a catalyst in the reaction? Because in terms of economy, most of the process involve catalyst. So we want to reduce the cost. We want to reduce the time of production. So that's why we use catalyst. Okay, and last ke? Okay, the advantages of catalytic process, we can achieve better process in terms of economics and productivity. Okay, by increase the reaction rate, simplify the reaction step. So in this case, we can reduce the cost to form the product, carry out the reaction under mild condition. Okay, so some of the catalysts, we can reduce the temperature and pressure required for the reaction compared without catalyst. Reducing waste, improving the selectivity toward the desired product. So I already explained previously. Replacing the harmful or toxic materials with readily available material. Okay. Then next, producing certain products that may not be possible without catalysts, having better control process, encouraging the application and advancements of new technologies and material. So this is the example of research that involve catalyst, so reaction kinetic and mechanism. So despite what you have learned, what will you will learn in this topic, so reaction kinetic and mechanism, okay, reaction path, intermediate formation and action, interpretation of result obtained under various conditions, generalizing the reaction type and scheme, predict catalyst performance. So a part of this study you will learn in this chapter. Okay, catalyst development, analysis technique. So your part tak adalah sampai. Ni kita just tengok the surface sahaja, reaction kinetic and mechanism in the surface. Okay, the theoretical part for the reaction kinetics and mechanism. Then ada juga reaction modeling. So yang ni you will use it during your during your design project later. Maybe some of you akan buat reaction modeling in your final year project later. Okay, reactor modeling tak adalah. Okay, and then catalytic process. Catalytic process it will involve heat and mass transfer, energy balance and efficiency of the process. So this one you will apply it in your design project later. Okay, and then catalysts also act as a promoter, substance which themselves are not catalysts, but when mixed in small quantities with the catalyst, increase their efficiency, are called as a promoters or activators. So this is how the promoters work. So platinum here, this is platinum. Platinum is the solid catalyst. Hydrogen is the reactant. And this is the promoter. Okay, but this promoters, this is a substance that act as a promoter. This is not a catalyst, tapi dia akan absorb on the catalyst to help increase the efficiency of this catalyst for the hydrogen reaction to occur. Okay, so this is an example of the process that involve the promoters to increase the function of catalyst. Okay, Haber process ataupun the manufacturing of methyl alcohol from water gas shifting lah ni. And then finally lah kot, catalyst and poison. So kalau yang previous one, catalyst as a promoter, it will increase the rate of reaction. But catalyst and poison, it will reduce the reaction ataupun eliminate the reaction because it will destroy the activity of catalyst. A substance which destroys the activity of the catalyst to accelerate a reaction is called a poison. And the process is called catalytic poisoning. Okay. For example, the presence of traces of arsenious oxide in the reacting gases, reducing the activity of platinized asbestos, which is used as catalyst in contact process for the manufacture of sulfuric acid. Okay, usually poison, catalyst and poisons ni substance that ataupun poison that to reduce the activity of catalyst ni, we use it for polymerization process because we want to stop the reaction. Kalau polymerization process ni, the process is continue to produce the product. So that's why we use the catalytic poisoning to eliminate the reaction. So the activity of iron catalyst is destroyed by the presence of H2S or CO in the synthesis of ammonia by Haber process. So this is another example of catalytic poisoning. And another example, the platinum catalyst used in the oxidation of hydrogen is poisoned by carbon monoxide. Okay, so this is just the example for the catalytic poisoning. And this is just for your information. Okay, so how the catalytic poisoning occurs? So this is the mechanism. The poison is absorbed on the catalytic surface in preference to the reactant. The catalyst may combine chemically with the impurity. So kalau tengok dekat sini, non-poison active site, you can compare it with the poison active site. So this yang blue color ni, this is the reactant that absorb on the surface of catalyst. The purple one is the catalyst. And this is the surface of catalyst, active site of catalyst. So the blue color is your reactant. But when the poisoning substance that act as a poison involved in the reaction, so it will absorb on the catalyst surface. So bila adanya poison substance here, therefore it will eliminate the formation of the product. Okay. So kalau tengok di sini, maksudnya the blue color tu cannot change to the product. The reactant cannot change to the product. Okay. Then another term, okay, involved in the catalytic reaction is inhibitors. So inhibitors ni the function dia similar with the poisoning. So inhibitors need to stop the reaction. So catalyst as an inhibitors, when a catalyst reduce the rate of reaction, it is called a negative catalyst or inhibitor. Yang ni dia sebenarnya the specific catalyst that we use to reduce the reaction. Okay, ataupun to eliminate the reaction. Kalau yang poison tadi, we add another substance into the reaction to stop the function of catalyst. Itu poison. But inhibitors, the catalyst is itself act as a inhibitors. That's the difference between poison and inhibitors. So a negative catalyst is used to slow down or stop altogether an unwanted reaction. Inhibition should be distinguished from catalyst poisoning. An inhibitor only hinders the working of a catalyst without changing it. While catalyst poisoning, the catalyst undergoes a chemical reaction that is irreversible in the environment in question. The active catalyst may only be regained by a separate process. So that's the difference between inhibitor and poison. Inhibitor ni memang the specific function is to slow down the reaction or to stop the reaction. So, and then the inhibitor not change the not change the process. Okay. Kalau poison, so we can compare the mechanism. Kalau poison ni memang change the process. It will produce another toxic product. So that's why we call it as a poison. And then ada juga that we call it as a autocatalytic reaction. Okay, autocatalytic reaction, when one of the product ataupun reactant of a reaction itself act as a catalyst for that reaction. The phenomena is called autocatalysis. So yang ni kita akan tengok in example later. What is the example of autocatalytic reaction? Meaning that you have the reactant and it will react to produce a product, to form a product ataupun intermediate product. And this intermediate product will act as a catalyst to increase the rate formation of the product. So, and some of the product ni, it will react back with the reactant to form another product. So the mechanism usually autocatalytic reaction ni involve a chain reaction. Chain reaction we will learn it in chapter 3 later. Okay, one of the example of autocatalytic reaction is chain reaction. Classification of the product yang ni homogeneous, heterogeneous, yang ni dah explain dah tadi, so tak payah dah. Okay, so kita nak tengok, kita nak go through specifically on the homogeneous catalysis ataupun homogeneous chemical reaction. So tadi kita dah explain the definition ataupun how to classify either it is homogeneous or heterogeneous. Okay, now we want to look further on the definition of homogeneous reaction. So homogeneous catalysis, catalysts and reactants are in the same phase. The catalyst is evenly distributed throughout the reaction. Reaction proceeds through an intermediate species of lower energy. There is usually more than one reaction step. Transition metal ions are often involved oxidation state change. So kalau if you look at this figure, for homogeneous reaction, so this is your reactant. Okay, reactant yang blue color and green color, this is the reactants. And this is the catalyst. Okay, solid catalyst. So, and then the reaction occur. Okay, let's say solid catalyst, they dissolve in the liquid phase. Okay, even though they still maintain the shape here, the shape still maintain, even though it is dissolved in the reaction. And this is your product. So, when the catalyst dissolve in the reaction, but the catalyst is still available in the liquid product here. So we can, how to separate the reaction, so you can filter the product. So product ni sepatutnya tak adalah keluar, dia still maintain dalam ni. So we need to filter the product from the catalyst. So yang tu adalah example how the homogeneous reaction occur with the solid catalyst. Okay, similar for liquid phase catalyst. Kalau involve a liquid phase catalyst, automatically the reaction is becomes homogeneous because both reactants and catalyst is in liquid phase. So how to separate the product from the catalyst? So we need to the product need to go through the separation process ataupun filtration process. Okay, some of the reaction is just required filtration process there to split the catalyst from the product. Okay, so heterogeneous catalysis or heterogeneous chemical reaction. Catalyst is in different physical phase from the reactants. It also called contact catalysis. It poses great industrial importance. So this is how the heterogeneous reaction. Yang ni lah yang you akan study in this topic. Lamol-Hissien-Wood, Ely-Riedel, precursor mechanism. So what is a Lamol-Hissien-Wood? What is Ely-Riedel? Actually, this is the mechanism of reaction ataupun the pathway on how the reaction occur. So it will involve the absorption of the reactant to the active site of the catalyst, and then surface reaction occur, desorption occur, and again another adsorption can occur. So yang ni kita akan fokus. These two, Lamul Hisherwood and Illyridial. Okay, a part of the mechanism of heterogeneous reaction. Okay, so, and then this is the shape of catalyst. Okay, porous catalyst, because porous catalyst is consists of large surface area, so that's why most of the reaction we choose porous catalyst compared to non-porous catalyst. And then the shape of catalyst, molecular sieve, dalam bentuk molecular sieve ataupun monolithic catalyst. So this is the example for different shape of catalyst. So tadi example dia dalam bentuk tubular. Yang previous slide tu dalam bentuk tubular. This one sphere. Okay, sphere catalyst. And then catalyst can be used as a supported catalyst or unsupported catalyst. Kalau support catalyst, this is the example of support catalyst. You need to attach it ataupun we call apa ke dia ada term dia. It's not attach, ada another term that we can call it for the catalyst that we use to another support. Okay, so support ni another type of metal. Kalau lah noble metal catalyst, you can attach it with the carbon ke ataupun another type of metal. Okay, so we call it as a support catalyst. Okay, kalau unsupported, yang ni. Okay, without any support. So let's say this is the alumina. So alumina without support. So you can leave it as this. Then just apply it in your reaction. So tak perlu another process to attach it with another metal to become a supported catalyst. Panjang juga yang introduction ni pun. Okay, yang ni composition of catalyst. Active phase where the reaction occur. So yang ni nanti, yang ni lah yang kita akan tengok. Where is the active phase? Okay, promoter increase the activity of catalyst. As a support or carrier. So catalyst can become a support or carrier to increase the mechanical strength, increase the surface area where the reaction can occur, may or may not be catalytically active. So tak semua part of your catalyst tu active site. Dia ada active site, dia ada non-active site. So this is the example on how the porous catalyst looks like. So the part where the reactant attached, we call it as a active site. And then kalau porous, there's a pore mouth where the reactant can absorb inside the pore mouth, okay, where it consists of active site. So if not, kalau non-porous, the active site only at the external surface sahaja. So the site where the reactant can absorb is very limited compared to the porous catalyst. Okay, then this is the example of catalyst used in the industry. Alumina, silica, zeolite, and then the support such as zirconia. So usually we use zirconia as a support, okay, support catalyst. For example, alumina catalyst, you can attach it with zirconia. So it's become supported alumina catalyst. Ataupun we call it as a alumina zirconia supported catalyst. So the main catalyst is alumina. Zirconia as a support. So yang ni again benda yang sama, kriteria, so repeating. So just apa tu, summary of this topic, introduction to catalysis. So yang ni boleh baca sendirilah later. Okay, we are done with part 1. Okay, kita break kejap. After this, kita masuk the most important part. So kita break for 5 minutes and then tak adalah saya nak habiskan apa slide part 2 tu semua. Kita just masuk introduction dulu. And then by next week, kita akan go further. Okay. So for today, after this, we will continue for part 2, kita masuk until steps in catalytic reaction sahaja. Okay, so break for 5 minutes. Alright. Kita sambung. Okay, sambung sikit lagi. Okay, kita dah start the most important part. Okay, steps in catalytic reaction. Okay. Boleh nampak tak? Can see the figure here.
Boleh.
Alright. Okay. So this is how the catalytic reaction occur, heterogeneous catalytic reaction occur. So this is the 7 steps of reaction involved for the chemical reaction on the porous catalyst. Okay, yang ni for porous catalyst. Okay, steps involved in heterogeneous catalytic reaction in porous catalyst. So what is A, what is B? Okay, in this example, okay, A here is the reactant, B as a product. So kalau tengok, this is the catalyst tau. Okay, 1, what is 1, what is 7? 1 ni step 1 and step 7. Step 7 ni the last step lah maksudnya. Okay, so this is the catalyst. This is the porous catalyst. That's why ada pore mouth. And then if we zoom this porous catalyst, this is how it looks like. Again, A is your reactant, B product. So this is the pore mouth. Okay, yang ni, yang stripe ni, this is the external surface of catalyst. So you kena imagine, this is one of the catalyst, spheres catalyst, one of the spheres catalyst. Okay, macam yang gambar tadi tu ada spheres catalyst banyak-banyak kan. You imagine satu daripadanya, one of the spheres catalyst. So it is porous. This is the pore mouth. So we can zoom the pore mouth as this one. So this is, kalau yang bulat ni je, spheres ni je, at the outside we call the external surface of catalyst. So this is the external surface of catalyst. And then pore mouth, because it's porous, so that's why ada lubang masuk ni. So we call it as a pore mouth. So step number 2 occur inside the pore mouth. Similar for step 6. Step 6 ni bermaksud keluar lah. Similar for this one. So what actually happened in step 1 and step 2 ni? This is what happened. Okay. Okay. A and B, this is at the bulk surface. Okay, bulk surface ataupun bulk fluid. So this is the boundary layer. Okay, at the bulk fluid, either it is liquid reactant or gas phase reactant. So at the bulk fluid, and then here, yang second dotted line ni, we call it as the external surface of catalyst. So this is the boundary layer. Okay, from the bulk fluid to the external surface. So the mass transfer of reactant A to the external surface of catalyst. Okay, kita fokus yang ni dulu. So gambar yang ni sebenarnya represent this one. Okay, sama je. Semua gambar ni sama je dengan yang ni. So this is the step. How the reactant attached to ataupun absorb on the surface of catalyst. So this is the external surface. This one is bulk fluid. And here is the boundary layer with thickness. Dia ada thickness dia. So how the reactant absorb? Reactant sebenarnya dia absorb. So berlakunya mass transfer from bulk fluid. Mass transfer of reactant A from bulk fluid to the external surface of catalyst. So this is step 1. Okay. Step 1 dia berlaku at the external surface. So kalau yang ni bayangkan this is your catalyst. Ini kat bahagian luar your fluid, either gas or liquid. Okay. So dia ada mass transfer. And then dia akan carilah. Okay, saya guna yang layman term, bahasa paling senang to explain how the adsorption occur. And then it will search, the reactor ni will search for the active site. Either dia nak masuk ke dalam, kalau masuk ke dalam dia jadi step 2. Kalau until external surface bermaksud your reactant A ni dia akan attach to the active site of catalyst at the external surface. So dia akan cari semua active site. So active site tu dekat catalyst tu dia ada active site and non-active site. The reactant only absorb on the active site. Kalau dia tak absorb on the active site, the reaction will not occur. It must absorb on the active site of catalyst. Okay, so dekat external pun ada absorption of reactant. Dekat dalam pore mouth, okay, step 2 ni dalam pore mouth. Yang ni dekat external. Dia ada mulut ni, dia masuk ke dalam. So, what happen when the reactant absorb inside of the catalyst? So, actually, there's a diffusion. So, macam mana reactant ni masuk ke dalam pore mouth? Through diffusion. Diffusion of reactant A from pore mouth. Pore mouth ni dekat bahagian luar lah, external. To internal catalytic surface. Okay, dia masuk ke dalam. Through diffusion process. Kalau dekat luar tadi, from bulk fluid to the external surface, mass transfer. Berlakunya mass transfer. And then, it will diffuse into the pore mouth. Okay, and then after diffuse, what happened? Step 3, adsorption of A onto catalytic surface. Adsorption of the reactant onto catalytic surface. And actually, step 3 ni berlaku juga at the external surface. So, adsorption of reactant A onto catalytic surface, dia berlaku at the external surface and internal surface. Yang aktif at the active site. Active site at the external surface and internal surface. Itu yang berlaku in step 3. Okay. Kena berlakunya adsorption. Adsorption of reactant must be occur. Okay, adsorption of reactant A onto the catalytic surface must be occur. If not, the reaction will not occur. Okay, then after the adsorption, maksudnya dia dah attach your reactant, dah attach to the active site of the catalyst through adsorption process. Then reaction berlaku on the active site of catalyst. So dia kata reaction on surface. Catalytic surface ni lah active site. Okay, reaction berlaku, reactant ni will react to produce the product B. This is step 4. Okay, step 4, reaction to produce the product. Okay, on the active side of the catalyst. And then, okay, after we produce the product, kita dah ada produk dah tadi. And then macam mana pula produk ni nak keluar balik, okay, from the active site. Sebab produk ni dia still attach dekat active site. Dia still absorb dekat active site of the catalyst. Sama ada inside the pore mouth ataupun external surface ni. Tak kira lah dekat mana-mana. Produk tu still absorb on the active site. So via desorption. So desorption of the product from the surface of catalyst. So kalau dia attach tadi via adsorption process, detach via desorption. Okay, so dia terbaliklah, adsorption and then kenalah ada desorption via desorption process of product from surface. And then remember, some of the product dia still inside the pore mouth. So macam mana dia nak keluar daripada pore mouth ni? Through diffusion. Diffusion of product B from pellet interior to pore mouth. So maksudnya step 6 ni, tengok gambar yang ni. Okay, produk dia nak keluar balik pergi ke pore mouth tu. So via diffusion. Dia masuk via diffusion, keluar pun via diffusion process. Okay. And then dia dah sampai dekat external surface of catalyst. And then dia nak pergi balik ke bulk fluid. Okay, dia nak keluar daripada catalyst phase ni. So diffusion of product B from external surface to the bulk fluid. Ataupun kalau confused, diffusion ni sebenarnya step 2 and step 3. You can change the explanation as mass transfer of product B from the surface to the bulk fluid. Itulah dia punya statement. So yang ni you kena tahu step by step from step 1 until step 7. So yang ni more simple lagi ni lah, lagi simple lah, more simplify compare to this one. Tapi kalau detail explanation, this is the detail explanation how the catalytic reaction occur. Okay, so kalau the simple explanation, so from A to ni, so yang ni tak nampak sangat lah what happened. So boundary layer saya dah cakap tadi yang ni. So yang ni very simple. But you can compare lah untuk tahu the process. So from step 2, 1 to 2, via diffusion, pore diffusion. So we also can call it as a pore diffusion. Mula-mula mass transfer from bulk fluid to the to the surface of catalyst, external surface of catalyst, and then pore diffusion of the reactant berlaku. Number 3, absorption onto the catalytic surface. Then reaction occur at the surface to produce the product. Okay, chemical reaction. So ini sebenarnya chemical reaction on the surface ni, active site of the surface. So that's why we call it as a chemical reaction. And then desorption sebab dia nak keluar. And then pore diffusion balik, nak keluar daripada dalam ni internal catalytic surface tu to the external surface. So last kali film diffusion. So that's why kita panggil diffusion juga. Sebenarnya mass transfer of the product tu back to the bulk fluid. Okay, so sama juga. So yang ni pun gambar yang ni sama tapi dia more simple compared to this one. Yang ni memang detail explanation how heterogeneous catalytic reaction occur. Okay, so yang ni you kena tahu. Okay, wajib tahu, bukan kena, wajib tahu. So this is compulsory for you to remember how the heterogeneous catalytic reaction occur. So yang ni again step by step. Okay, step 1 until 7. Okay, so step 1 tadi, yang ni lagi details lah explanation dia. Okay, based on this figure. So this is the complete explanation on how the reaction occur. Step 1, external mass transfer of the reactants. So kalau tak nak confuse, gunakan perkataan external mass transfer compared to diffusion lah. So external mass transfer of the reactants from the bulk fluid to the external surface of the catalyst pellet. And then pore diffusion of the reactant from the pore mouth through the catalyst pores to the immediate vicinity of the internal catalytic surface. Kalau susah nak ingat, guna je ayat yang ni. Pore diffusion of reactant A from pore mouth to the internal catalytic surface. So you can choose. Either you want to explain by using this sentence ataupun this sentence. Mana yang senang you nak explain. Okay. And then step 3, absorption of reactant A onto the active site of the catalyst surface. Step 4, reaction on the surface of the catalyst. Step 5, desorption of the product from the surface. And then step 6, pour diffusion of the products from the interior of the pellet to the pore mouth at the external surface. And finally, external mass transfer of the products from the external pellet surface to the bulk fluid. So sebenarnya 1 should be similar with step 7. Step 2 should be similar with step 6. Step 3 dia terbaliklah absorption. Step 3 absorption, step 5 desorption. So step 4 is the reaction. Okay, so yang ni when the reaction occur in porous catalyst. Right, what happen if the reaction occur on non-porous catalyst? So if the catalyst is non-porous, step 2 and step T can be negligible because there is no pore diffusion. Okay, for non-porous catalyst, step 2 and step 6 will be negligible. Okay, kalau non-porous, there is no pore mouth. Macam mana nak berlaku? There is no internal diffusion. Okay, so the reaction only occur at the external surface of the catalyst. So kalau for non-porous, only at the external surface. So yang ada only step 1, step 3, step 4, step 5 and step 7. Step 2 and 6 negligible because there is no pore mouth. Okay, yang tu for non-porous catalyst. Okay. So I think we stop until here. Okay. So next week kita akan go further. Okay, step by step. What happened in step 1, step 2, sampailah step 7. Kita akan go through one by one. Okay, for each steps of reaction and then apa calculation yang kita akan tengok. So this one we will, I will explain it in next week. Okay, step 1 dengan step 2 ni still okay lagi. Yang ni the most critical part is step 3, step 4 and step 5. So start from here, there's a lot of derivation of equation involved. Okay, so yang ni semput lah nanti. Okay, kita kena kejar masa lagi. Okay, so that's why saya cakap it's not enough for us to cover this topic within 2.5 weeks. So at least kena ada 3 weeks. So sekarang ni Monday dah cuti hari tu, so we only left 2.4 weeks jugalah, sepatutnya 3 weeks kita boleh cover. So later multi-phase reaction dengan chain reaction kita boleh cover within 3 weeks. Itu simple. Okay, chapter yang chapter chain reaction tu agak senang dan sedikit compare to this chapter, especially for this part. And then my plan for this part later next week, I will give lecture for this part on next Thursday juga. So kita akan buat face-to-face class, okay, for this step, okay, because yang ni critical, so kita akan buat face-to-face punya class. Next Monday untuk step 1 dengan step 2, together with the example of the question related for this part, kita akan buat online. Okay, so next Monday, class online. Next Thursday, kita akan buat class face-to-face on the derivation of reaction kinetic. Okay, so for today, we just stop until here. Okay, so after the class, you can read again apa yang you ni, especially on this part. Okay, you can read and then try to understand how the reaction occur. Okay. Dia auto stop presenting. Okay, so that's all for today. We meet again next Monday. Okay, thank you for your time. And saya akan schedulekan meeting maybe next Sunday ke saya akan schedulekan the link for the meeting. Okay, so thank you very much. We can leave now. Assalamualaikum.
Thank you, Doktor.
Thank you, Ida.
Thank you, Doktor.
Thank you, doktor.
Thank you, Doktor. Thank you, Doktor.
Thank you, Doktor.